Welcome to The Explainer, made by Forge College. All right, last time in our capstone lesson, we actually assembled our Solidity to Rust pattern catalog. We mapped out all those familiar EVM concepts and, really took the time to understand the theoretical shifts. But today is moving day. And look, just like moving out of a house you've lived in for years, you can't just shove everything into boxes, throw them in a truck, and hope for the best. No way. You need a solid plan. So today, we're laying out the strict architectural blueprints to transition your entire development workflow. We're leaving the comforts of Hardhat and Foundry behind, and we are migrating to the SVM with the Anchor framework. We're not just moving code today, folks. We are preparing your entire engineering workshop. Okay, let's quickly dive into the engineering blueprint of exactly what we're covering today. We've got 5 phases to prep your workshop for the Anchor ecosystem. First up, setting the scope. Second, the inventory audit. Third, workflow mapping. Fourth, script conventions. And finally, your setup checklist. Let's get straight to the foundation. Phase 1. Setting the migration scope. This is the absolutely crucial strategic planning step we have to take before we even think about downloading new command line interfaces. So what exactly is our migration scope? Well, we're talking about ruthlessly enumerating everything, every single repository, every deployment script, your continuous integration jobs, and all those bespoke duct tape developer tools you've built up over the years. Defining this scope upfront is literally your absolute best defense against environment conflicts later down the line. I mean, we all know the nightmare of half the dev team using a different toolchain version, right? Or relying on some globally installed NPM package from like 3 years ago, which just results in those endless, well, it works on my machine arguments. Doing this architectural homework right now, cataloging exactly what needs to be moved, will dramatically speed up the scaffolding process when we actually start writing and deploying on Solana. Phase 2, the inventory audit. Now, what's really interesting about this next concept is how we systematically triage all those EVM tools currently cluttering up your workspace. To make this audit work, we're going to use a beautifully simple rule of 3. Adopt, adapt, or archive. Take a hard look at your current toolchain. First, can we adopt a direct Anchor equivalent? If not, do we need to adapt it by rewiring the underlying logic? Or, third, and honestly, this is the most therapeutic one, can we just archive it? Because let's be real, not everything is coming with us on moving day. Like those convoluted EVM gas estimation scripts that constantly break and throw vague revert errors? Archive them. Burn them. Solana's localized fee market is entirely different, so we drop that dead weight for historical reference only and just move right along. And here is exactly what that parts replacement triage looks like in practice. On the EVM side, your trusty hardhat.config.js becomes anchor.toml. That's going to handle your network routing and workspace config. Your deploy scripts swap over to the Anchor CLI. But here is the absolute massive paradigm shift. Instead of compiling to EVM bytecode and getting this massive clunky artifacts JSON file with your ABI, Anchor compiles to BPF, Berkeley Pocket Filter Shared Objects. Now, BPF was originally designed for ultra-fast network packet filtering, but Solana adapted it for incredibly fast, safe, smart contract execution. And instead of an ABI, Anchor generates an IDL, an interface description language. This IDL is way more than just a function map. It securely and explicitly defines the specific account structures your program expects. Finally, your Foundry or Hardhat tests, those will adapt into native Rust or JavaScript tests running against an Anchor localnet. Phase 3. Mapping your development workflows. Let's shift our focus from individual tools to the actual sequences we use to build software. Development workflows can feel like this massive, tangled web of commands, but we can actually flatten it all out into a strict, logical sequence. Compile, test, deploy, NCI, and monitor. By breaking down the big, scary development cycle into these logical sequences, we expose exactly where the familiar EVM path and the new Anchor path diverge. And spoiler alert, the Anchor path is about to move a whole lot faster. Let's zoom in on that compile step for a second. Think of this like a giant manufacturing plant. Over on Ethereum, you input Solidity, the machinery cranks it into EVM bytecode, and the output you get on the loading dock is a JSON ABI. But the Anchor plant operates completely differently. You feed it Rust, it compiles down into BPF bytecode, which, remember, is a highly efficient shared object file, and the final product is your IDL. This matters heavily for your migration scope. Why? Because if you have automated downstream scripts, indexing services, or front ends that rely on parsing a standard Ethereum ABI, you have to completely rewire them. They now need to parse Anchor's ideal types and account schemas instead. It's a fundamental change in how your off-chain architecture communicates with your on-chain logic. Next up is testing, which, to be totally honest, is the biggest upgrade to your developer experience. We can finally say goodbye to those brittle EVM mainnet forking tests that randomly time out on your CI pipeline and just totally ruin your day. Moving to Anchor, we recommend a two-track testing approach. In the short term, you'll use JavaScript adapters to run tests against the lightning-fast Anchor localnet. But your ultimate, long-term goal should absolutely be writing native Rust unit and integration tests. This lets you execute logic incredibly fast directly inside the native cargo framework. You can test your core business logic often without even needing to spin up a local validator. The feedback loop is night and day compared to waiting for a Hardhat node to sync. And of course, we absolutely cannot forget our automated gates, the CI pipeline. When you're migrating, you'll need to completely tear down your old Hardhat or Forge CI test jobs. In their place, you need jobs that install Rust, the Solana toolchain, and Anchor. Now, here is a massive pro tip. You must strictly pin your Rust and Anchor versions. The Solana ecosystem moves exceptionally fast, and leaving versions floating is a guaranteed recipe for surprise build failures on a Friday afternoon. Nobody wants that. You'll also want to map your old Etherscan verification steps directly to the Solana Explorer and add a pipeline step to automatically publish a new IDL so your front ends always have the latest interface. Phase 4. Comparing deployment script conventions. Let's move along and see how this builds into reality with a practical code walkthrough. When we look at deployment scripts, the underlying philosophy completely changes. With standard Hardhat JavaScript, you know the drill. You call ethers.getContractFactory, you hit deploy, and the EVM magically infers a massive amount of context for you based on positional parameters and msg.sender. Anchor TypeScript behaves very differently. The actual on-chain deployment is handled natively by the Anchor CLI, meaning your TS script is primarily for client interaction and state initialization. But the absolute most critical shift here is that Anchor requires an explicit accounts map. You cannot just pass arguments positionally and hope the network figures out who is paying. No way. You must explicitly declare every single Solana account involved. You're generating a new key pair for a data account, explicitly declaring the user wallet that is paying the fee, and even passing the core system program. It feels a bit verbose at first, for sure, but this explicit mapping is exactly what makes Solana programs parallel processable and incredibly secure. There is absolutely no hidden state magic here. Phase 5, your final setup checklist. So the crucial point here is consolidating all this strategic planning into a concrete packing list for the move. Here are the exact deliverables you need packed up and in your hands before we take the next step. 1. An annotated toolchain inventory where you've ruthlessly decided exactly what to adopt, adapt, or archive. 2. A fully mapped CI pipeline requirements list so you know exactly what versions of Rust and Anchor your build servers need. And 3. Select at least one high-priority EVM test file to act as your guinea pig for adaptation into the Anchor testing framework. Get these 3 things ready and you will be completely prepared for the technical installation. So, I'll leave you with this final provocative thought. Are you truly ready to leave the EVM behind? Because you have the blueprints now. You know the exact architectural scope required to prepare your environment for the SVM. In our upcoming explainer, Install and Configure Solana and Anchor CLIs, we're going to take this packing list and finally get everything set up. It's going to be an absolute blast. Thank you so much for joining me today. This explainer was made by Forge College. I highly encourage you to visit forge.college to learn more about this subject, dive deeper into the Anchor framework, and explore a wealth of other fascinating Web3 topics. Until next time, keep building.